Hello! Untitled Chapter, Mr. Lawrence here, and this is part 2 of the review video. I've got 2 problems up here on exponential growth and decay. See if you can knock them out. Pause the video, see if you can do them. Here come my solutions. If you haven't tried to pause the video, why won't you listen to me? All right, to do this problem, I'm going to use the formula A equals P times the quantity of 1 plus or minus R. And remember, when I do R, it's the percentage as a decimal, right? To the power of T, and T must be the time in years. So it says for part A, what will the population of the town be 7 years from now? Well, I'm going to put the current population in. That's my P. My principal, not my Mrs. Armentrout, my principal. She's my principal. And then I have 1 plus 3/100ths. And I'm going to raise that to the power of 7, the time in years. And here's where I like to go to my calculator. I don't want to do all this work or do it piecemeal. I'm going to go right to my calculator. There it is. And I'm not sure what that is, so I'm going to go 12,500 times 1 plus 3/100ths. And I believe I'm raising it to the 7th power. And when I do that, I get approximately 15,373. By the way, if that decimal had been like 0.89, I would not have rounded up because I don't have whole people yet. I would round down because you can't have 80% of a person. So I would have rounded down in that situation. All right, if that had occurred. So it's pretty simple. Now, the next problem says, what was the population of town 5 years ago? Well, the way Mr. Lawrence likes to do it now, thanks to a former student named Ben Krieger, he likes to go -5 there because I'm going 5 years ago. And if you watch, I'm going to get this answer, 10,782. And there's a decimal there, but I'll just round down because we're talking whole people. Now, if I'm Chris Contra or possibly Logan Isley, I may do it this way, and there is nothing wrong with this. That's why I'm taking the time to show you. Put 12,500 in A's position, and then I'm going to use 0.03 and put that to the -5th power. Now I could, that should be the +5th power, my mistake. I'm almost positive that doing it with a negative exponent is the same as doing it this way. I'm 100% sure that this is. I'm almost 100% sure that it is not okay to just change this to a loss of 3% per year. It is not the same problem, okay? If I did like 12,500 at a 3% loss for 5 years, that's not the same as the growth. You'll get a slightly different answer. So if I'm going to do this, I'm going to have to divide both sides by 1 plus 3/100ths. Quantity raised to the 5th power, okay? But you will get the same number. All right, here's another problem. Sam invests $600 in the bank at a rate of 1.5% interest. If the money will be compounded quarterly, what will the investment be worth in 18 months? Now, one thing I might do right away, go ahead, pause the video, you try it. All right, here I come. One thing I might do right away is I might put that as 1.5 because I want the time in years, not in months. Okay, and I'm going to do 600 times the quantity of 1 plus, convert that decimal to or fraction to a decimal, but I'm going to put it over 4. Why 4? Because quarterly means 4. I'm compounding it 4 times a year. Now, I'm going to raise that to the T time in years, 1.5, times the compounding, which is 4. The official formula is P times quantity of 1 plus or minus R divided by N, where N is the number of compoundings per year, and raised to the power of Tennessee, or rather T times N. Okay, but that's how it'll look. Now, if I go to my graphing calculator at this point, By the way, I know that 1.5 times 4 is 6, right? So I'm going to go to my graphing calculator, and let me clear this off. And I'm going to do 600, 600, oh dear, 600 times a quantity of 1 plus, and I can go 0.015, and then I'm going to divide that by 4. I don't need any extra parentheses in there because the calculator understands the order of operations. Inside this quantity, it'll divide 15 1,000ths by 4 and then add 1 to it. Then I need to go with an exponent, and my exponent was 1.5 times 4, or otherwise known as 6, right? And I hit enter, and I get $613.63 approximately. Seam says it's not a lot of money, but if you just left it sitting in your piggy bank, Seam, how much would you have a year and a half later? Only what you put in the piggy bank, right? So this way, at least the money is growing. All right, the more you put in, the more it grows. Okay, geometric sequences, and I have a mistake here. Where are you? There you are. I have a mistake here. I believe I have this wrong because this is supposed to be the, it won't let me edit it. I'm just going to cut it out of there. All right. The first formula I have here is the explicit formula, and that's the one I'm so partial to because it allows you to figure out any term in the sequence. So that's the explicit formula, right? You take the first one, you multiply it by the common ratio raised to the power of n minus 1. So if I'm looking for the 8th term, I'll be raising r to the 7th power. Okay. Now the recursive formula, which I don't like so much because it's not as useful. Okay, it has its place, but it doesn't really do much for me. It's going to give me the nth term if I multiply the term before it, so that would be a to the power of, or a sub n minus 1, the term before the nth term, and I multiply that by whatever the common ratio is. So there's the recursive formula. That's supposed to be an a there. Okay. So let's use these formulas on these sequences here, and let's try to find the 8th term of this sequence. Well, the first thing I do is I go looking for r. And I can find r by asking myself either what do I multiply this term by, the 1, to turn it into 4, or I can divide the second term by the first, or the third by the second, or the fourth by the third. And in either case, I'm going to get 4 for my r. So a to the 8th, if I want to find the 8th term, a sub 8, I'm going to take 1, and I'm going to multiply it by 4, which is r, and I'm going to raise that to the 7th power. And that should work. Now 4 to the 7th power is going to be pretty big. Let me see. This is 0 power, 1st power, 2nd power, 3rd power, 4th power. Okay, so 5th power is going to be 1024, right? The 6th power, 2048. 2048, so that'll be 496, 4096. This puppy is getting big quick. All right, and if I double that, I'm going to get 8, 196, and then 16, 392, I think. I think that's right. It's really a big number. Let's see what we get here if I do 1 times 4 to the 7th power, right? And let's see what we get. 16,384. So I made a silly mistake along the way somewhere, probably a carrying error. But there you go. That would be the 8th term in the sequence. Okay? All right. So that is the explicit formula, and I got a couple more for you to practice on here. Why don't you find me the 20th term of this one? Yeah, find the 20th term. Okay, so a sub 20. All right, and then there's one more here. You can find me the, I don't know, the 9th term, a sub 9, okay? Go ahead and pause the video, and when you're ready to see the solutions, my solutions, let me know. All right, here come my solutions. So first I'm going to find r, and it looks like r is going to be -1. And so I'm going to take a sub 20, and that's going to equal 7 times -1 to the 19th power. Well, -1 to the 19th power is going to be -1, isn't it? Times 7 is going to be -7. And I like that because notice the first term, the third term are both positive. The fifth term is going to be positive. So that means the odd numbers are all positive, the odd terms, and the even number terms are all negative, and 20 is an even number term. So I really like how that turned out. Okay, coming down to the next one. All right, let's see here. Let me go find r, and it looks like r is going to be 1/5. If I do 25 divided by 125, and I simplify that fraction, I believe I'm going to get 1/5. So to find the 9th term, I'm going to take the first term, 125, and I'm going to multiply it by 1/5 raised to the 8th power. Now, this is really easy because I know 125 is, well, I'm going to leave it as 125, right? And I'm going to put that over 5 times 5 times 5 times 5 times 5 times 5. What am I at there? 5 5s? 6 5s, 7 5s, 8 5s. Now I've got one too many, don't I? 3, 4, 5, 6, 7, 8. Yeah, I got one too many. Okay, so let me get rid of that extra one there on the end. And one thing I want to point out to you is I'm going to do some canceling out here because this is 125. So these 3 5s can cancel with that 125. And so I'm left with 1 over 5 to the 5th. Now, I know 5 to the 4th is 625. I think this is going to be 3125. I think a to the 9th is going to equal 1 over 3,125. And how do I know that? Because I've been doing this for so many years. All right, so let's just double check that though. Let's go to the calculator. And let's see here. I should have 125 times 1/5. And we're going to raise that to the, I forgot, 8th power, I think, right? And we got this weird scientific notation number, okay? I don't think it's going to let me do a math frac on it because it's in scientific notation, but I'll try. Oh, it did. Excellent. So 1 over 3,125, and there you go. All right, that's part 2 of the video. Part 3 will be coming up shortly.